14.286. Okay, 11.286, 13.144, 31.286. You take the first term outside. Taking the first term outside, it is 1. 33.14 divided by 11.286, it is 2.94. 41.286 divided by 11.286, it is taken outside, it is 3.66. So now we have the new displacement. Okay, you continue this trial until you will get the same displacement values in this successive session. Okay, I'll use the Excel to calculate the same thing. So 421 484 already taken here, 421 484 487. When these are the initial displacement 1 1 1. When these two matrices are multiplied, the values are 7 16 19. Okay, let us take this first term outside, 7. Taking the 7 outside, the new displacements are 1 2.29 2.77, 1 2.229 2.77. When these two matrices again multiplied, it is 13.53 42.13 53.13. When 13.53 it is taken outside, now we have these new displacement. Okay, we are doing the iterative method. For this new displacement, let us calculate the again new. Okay, now 14.15. Taking 14.15 outside, now we have this displacement. Okay, we are doing the same iteration process for a more number of iterations. See here, 1 is converts to 1, 3.15 it is 3.16. See here, displacement 2, it is merging to some value here. Okay, 3.11 it is converted to 3.15, 3.15, 3. It is almost close to each other. Taking the new displacement, so here for the sixth trial we have the same displacement. Okay, let us stop for this trial 6, as we have same displacements in the trial 5 and trial 6. So displacement of the mass 1 it is 1, displacement of the mass 2 it is 3.16, displacement of the mass 3 it is 4. Now we have taken 14.32 outside. See here, 14 point, it is almost close answer with the Excel. Okay, omega square m by 3k. For this value I stopped 14.284. The mode shapes are 1 3.164. Okay, to find the natural frequency of the system, okay, let us equate this as the equal to 1. 14.284 omega square m by 3k, it is equal to 1. You find what is omega. Omega value is 0.46 square root of k by m. It is the first natural frequency, and the mode shapes are 1 3.164. Okay, this is the first natural frequency. Now we will see the next, we will continue to find the second natural frequency. To find the second natural frequency, we are using the orthogonality principle. We have already discussed what is orthogonality principle in the previous video. Okay, this is the orthogonality principles. For 3 masses, it can be written as x1 of 1 m1 x1 plus x2 of 1 m2 x2 x3 of 1 m3 x3. What is x1 of 1 x2 of 1 x3 of 1? These are the amplitudes for the first mode shapes. For the first natural frequency mode, the x1 of 1 it is 1, x2 of 1 it is 3.16, x3 of 1 it is 4. So, and m1, mass 1 it is 4m, mass 2 it is 2m, and mass 3 it is m. Okay, we are using the orthogonality principle. Okay, we are using the orthogonality principle. Okay, substituting x1 of 1, x2 of 1 and x3 of 1, it is 1 3.164, and masses are 4m, 2m and m. Now we are writing these equations. Substituting this equation, it is 4m x1 plus 6.32 m x2 plus 4m x3 equal to 0. Mass is common in all the terms. So it can be cancelled. So x1 can be written as x1 is equal to minus 1.5 x2 minus x3. Okay, by orthogonality principles, now we have this equation: x1 is equal to minus 1.58 x2 minus x3. M cancelled here. 4x1 is equal to minus 6.32 3 to x2 minus 4x3 divided by 4, it gives minus 1.58 x2 minus x3. By the first orthogonality principle, now we have this equation: x2 is equal to x2, x3 is equal to x3. Okay, let us write these three equations in this form: x1, x2, x3. Okay, it is in terms of displacements: x1, x2, x3. As in this equation there is no x1, so it is 0. The coefficient of x2 it is minus 1.58, and the coefficient of x3 it is minus 1. In the second equation there is no x1 and x3, so x1 coefficient, x3 coefficient is 0, and x2 coefficient it is 1. In the third equation, x3 is equal to x3, so x1 coefficient, x2 coefficient is equal to 0, and x3 coefficient is 1. Okay, this new matrix, it is called as the sweeping matrix. This matrix, it is sweeping matrix. We are using this sweeping matrix to find the natural frequency. We already know that we have represented, to find the first natural frequency we have used this matrix form: x is equal to omega square a into m into x. This is the dynamic matrix. Now we are using the new dynamic matrix. The new dynamic matrix, it is a multiplication of the sweeping matrix and the old dynamic matrix. This is the sweeping matrix. This is called as the sweeping matrix: 0, minus 1.58, minus 1, 0, 1, 0, 0, 0, 1. Okay. Okay, let us represent x is equal to x1, x2, x3, omega square as it is. In the dynamic matrix, it is a multiplication of influence coefficient matrix and mass matrix. In the mass matrix, in all the elements m is common, so it is taken outside. So it is 4a1, 2a1, 2a13. The dynamic matrix, it is multiplied with the sweeping matrix here. Okay, to find the second mode shapes and the second natural frequency, we are multiplying the dynamic matrix with the sweeping matrix. This is the additional matrix here: x1, x2, x3. And in all the influence coefficients, 1 by 3k it is common, so taking 1 by 3k common and multiplied this matrix and this matrix, we have the new matrix here: 0, minus 4.38, minus 3, 0, 1.68, 0. Okay, now let us assume x1, x2, x3 as the initial displacement as 1, 1, 1. Okay, we are doing the iteration process as we did it for a first natural frequency. Let us take this new matrix. Okay, it will take 0, minus 4.32, 0, minus 4.32, minus 3. Okay, let us consider this new displacement as 1, x1, x2, x3 as 1, initialize. Okay, so it is minus 2.91, 7.38 outside is minus 7.38, so the first new displacements are minus 1, 0.23, 0.64. You can check here: minus 1, 0.23 and 0.64. What it is taken outside, it is 7.32. Okay, similarly next 2.91 for the next iteration, we have taken minus 1, 0.23, 0.64 are the new displacements. Okay, minus 1, 0.23, 0.64. Okay, multiplied with these two matrices, it gives minus 2.94. you can see here. Okay, it is 2.91. we have taken 2.91 outside. So similarly we will see for what trial we get the closer values. New displacements 2.95, sorry, 0.08, it converts to 0.04. See here, 0.04 converts to 0.08, 0.3, almost it is same value. Okay, almost it is same value. You can stop here. It is always same values. Okay, 2.99, and these are the new mode shapes.